Welcome everyone. In this video lecture, we will think about the CMOS noise margin calculation. So what is the noise margin calculation that we will cover in this video? So as we are aware that this one is the CMOS inverter circuit. Okay. CMOS inverter circuit means there is a PMOS, NMOS network. The gate of both the NMOS and PMOS are connected to a input and we are taking output across the drain in. Okay, so this one is basically our gate of PMOS transistor. So gate of NMOS transistor. This one is source terminal. So I am writing source of P. This one is drain of P. And this terminal is drain of N. Arrow sign always shows the source terminal. So this one is a source N. So no need to write, but better to write. Okay, it will better to write. Okay, so and we are taking output across this side. So the corresponding output versus input characteristics. This one is our input, sorry. V output versus V in characteristics is I have drawn. Okay. In which this one is our output high voltage VOH. VOL is the output low value. Okay. And VIL is the input low value. Okay. Input low value, input voltage. And VIH is the input high voltage. So these are the four critical parameters. So after that we will think about noise margin. So first better to think about this VOH, VOL, VIL and VIH are the four critical parameters I am writing here. There are four critical parameters. Okay, so there are four critical parameters. Okay, and so there are four critical parameters. So the very first one is our VOH. So VOH is the output high level voltage, or better to say output which is maximum. So better to write maximum output. I am writing maximum. Okay, this is the maximum output. Output. So I am writing output maximum output voltage when the output logic is one output level or output logic, you can say one. Okay, this one is the maximum output voltage when the output logic one, we can say when the output logic one. Okay, and VOL, the other term, other parameter, critical parameter, VOL is the minimum. Okay, minimum. So better to write minimum. This one is OL. So output. Okay, low voltage, minimum output voltage when the output level or output logic is simply our 0. Okay, now the other parameters are VIL. Okay, VIL, we can write maximum input. Why I am writing maximum, I will tell you. Maximum input which can maximum input which can be interpreted as logic 0. This one is the VIL. This one, this up to this VIL. Okay, is the maximum input which can interpreted as logic 0 input. Logic 0. Okay, maximum value will be VIL. Before that, it will give the lower value in which output is high. So maximum input value. Okay, that can be interpreted as logic 0. Now one more thing is there, that is our VIH. So we can write VIH is the minimum input which can be interpreted as logic 1. Okay, why I am saying logic 1? Because this one is the minimum. Okay, after that it will give the logic 1 input, high value of input, but this should be the minimum. That's why this one is a VIH. We can say the minimum input which can be interpreted as a logic 1. So this one is a minimum input which can be interpreted as a logic 1. Okay, so these are the four critical parameter. So noise margin will be based on these parameter. So there are two things in the noise margin. So before that I want to write the definition of the noise margin. So I am writing here. So what exactly means noise margin? Okay, noise margin. So basically noise margin measures measures the ability of an inverter. Okay, measures the ability of the inverter. Actually noise margin measures the ability of the to inverter to tolerate tolerate the variations in the tolerate the variations in the input signal input signal or input signal levels, we can say. So actually noise margin measures the ability of the inverter to tolerate the variation in the input signal level. So if input signal variation in input signal maybe arises due to some noise. Okay, so if some noise is coming, okay, so what should be the variation and how much the inverter can tolerate, how much noise. Okay, clear? So noise margin measures the ability of the inverter to tolerate the variation in the input signal levels. Okay, so for this purpose I am just think about the uh, miss noise margin concept. We are going for a what we can say, the a network which consists of uh, two inverter. Okay, two inverter here and one more inverter. Try to add one more inverter, three inverter. Okay, say one more inverter. Basically to illustrate the concept of noise margin, we are coming with a three inverter circuit. Okay, one, two, three, and all inverter are connected in cascade manner through a interconnect. Okay, so this is an interconnect mainly consist of metal or polysilicon line. So basically this one is either metal or polysilicon. Okay, so this one is the some interconnect is there. So to illustrate the concept of noise margin we are using three inverter circuit. Okay, and in between them two interconnects are there, and we are giving a output high value. So if we are giving a output high voltage VOH from the first inverter, the corresponding output at this side will be simply our low value VOL. Okay, VOL. Okay, and there is an interconnect. Okay, so basically this interconnect having the metal or polysilicon structure, or sometimes it is some cheap interconnect. Okay, and generally it is prone to some noise. Okay, it is prone to some noise. Okay, so if it includes some noise, okay, when we are transmitting the input from this side to inverter to input. Okay, so what exactly it will do, I'm going. Okay, so the output high value we are giving at the first inverter input. Okay, and we are getting VOL, but after this VOL, and at this inverter at this inverter stage, our output will be high. We need a high value of output, okay, for a better result. Okay, but there is some noise is introducing in between the interconnect. So this VOL will be either increased by some voltage, say del V, or it may decreased by some voltage del V. Okay, means basically this VOL in between these two. Okay, means for this interconnect, I am just once again writing VOL is the this input value, but there is some interconnect. So due to interconnect, some noise due to this interconnect are generally prone to signal noise. Okay, so it is prone to signal noise. So the output signal of the first inverter, that is our VOL, the output signal of the first, our VOL will be perturbed during transmission. This value will be perturbed, and it may be either VOL plus, here we can say VOL plus del V, some voltage is coming due to the, and here VOL. Okay, it may either increase to this, or it may decrease to some voltage level this. Okay, there are two possibility. So from the figure we can say this one is our VOL. So this voltage level we can say this one is VOL, and this value we can say VOH, or simply VDD. Okay, VOL, this voltage is separated to this. So if we are going in this side due to noise, if we are going to this side in the inverter, okay, just think this diagram. Okay, it will give the logic high value VOH. Okay, so there will be no change, there will be no effect of the noise when VOL minus del V will work. But if we go beyond this side, VOL in that side, up to how much voltage it will give the high value, that is our VOH. We need VOH. So up to how much? So up to VIL it will sustain, or it will results the VOH. So this much is the voltage. VIL is the voltage that will, up to VIL it will give VOH. Okay, so in between this VIL to VOL, this much amount of noise margin will be okay. So this kind of thing is our NML. Okay, so this one is our NML. Okay, that is our noise margin for low input. So I am writing here. Okay, so for this side, if we move toward this side, so it will better to go up to VIL. That will give the logic high. It will give the logic high output value. Logic high output value. That is our value. Value. That is our VOH. Okay, up to VIH. Okay, so this one. is the range. Okay, that is called as NML. Okay, NML that means simply VIL. Okay, minus VOH. Okay, NML VIL minus VOH. So this VIL minus VOH, and this one is called as the noise margin for low input. Noise margin for low input. Okay, clear? Means if this one is for to illustrate the concept of noise margin, we are considering three not gate. Okay, inverter, and giving high value of voltage. So we are getting a low value, and there is some interconnect. Okay, and this interconnect is metal or polysilicon or cheap interconnect, which is prone to noise. Okay, and overall output of the second inverter we will get VOH we require. This is our desire. So how much input voltage it can we will have to take, that will give the proper result. So after introducing some noise, or due to some noise, the output, the VOL is perturbed to VOL plus some voltage, or VOL minus del V. So if VOL minus del V, some voltage less, it will give the logic high, that is our VOH. So there is okay, this part is okay. Now if we go beyond VOL, so up to how much value it will give the proper high value of output VOH. So up to VIL, where dV out by dV is minus 1. So it should be our VIL. So this difference VIL minus VOL is called as the noise margin for low input. For low input, noise margin will be VIL minus VOH. Okay, sorry, VOL. This one is VOL. No? Sorry, this one is VOL. Okay. Similarly, so now this one is finally we will get here VOH. Now this one is VOH. So here what we need here, after third inverter, second inverter output VOH. So third inverter output, our desire is it should be our VOL. Okay, VOL is the okay. So again this one is some interconnect. So suppose some noise is there. Okay, so the output of the second inverter give VOH, and due to this noise, the VOH value may be either increased to some voltage or either decreased to some voltage del V. Okay, clear? Where this I am saying this VOH is either this or this. Okay, so just I am taking on the number line. So this VOH, if we going towards this, it is VOH plus del V, and on that side it is VOH minus del V. So if we are going towards this side, okay, towards right hand side, okay. So if we increase the value, okay, below above VOH, means this one we are taking the VDD, okay, it will give the low value we are required. So this one will work okay, means if some noise is there, it will give the same result for the low value VOH. But if we go on the left hand side, so up to how much value it will give the VI low value? Up to VIH. Up to VIH, it will give the proper result. VIH. Okay. So this value will be our VIH. Okay. So now the noise margin for this case will be VOH. So this range NMH, I am writing it, this is a NMH. So this NMH is our what? Noise margin for high input. noise margin for high output. Noise margin for high output, NMH, will be our simply VOH minus VIH. Okay, okay. So it is observed that this one is our means noise margin for high input, and this one. Okay, so this can be once again. I just want to. Okay, so if this one is our, we can easily, no need to remember the noise margin concept. Okay, so if this one is our some tangent at that point, tangent at that point, and this point is our input low value, input high value. Okay, this point is our VOH, and I am saying this one is our VOL, and this one is constant. After this one is our VOH, that is our VDD. Okay, and this value is VOL, so I am saying this one is also VOL. Like suppose 1 volt, so this one is also 1 volt, so I am saying VOL. So this one is the for your NML, noise margin due to low input, and this difference is called NMH. So NMH is nothing but simply VOH minus VIH. Okay, and this one NML is nothing but simply VIL. This value minus VIL minus VO. Okay, so this is all about the noise margin concept, and I have taken this concept from the uh, Kang book. Okay, this is all about the noise margin concept. So you can also say this one is your NML, that is our VIL minus VOL. Okay, noise margin, and this one, this range is our NMH VOH minus VIH. And through this diagram, we can illustrate the concept of noise margin. Means if VOH is the input, output is VOL. So how much input, some noise is there. So how for a proper output VOH as a second inverter output, the range will be up to VIL. Okay, so in between VOL to VIL, there is a noise margin, that is our NML. Now if VOH, so we have to get the VOL after the third inverter, so it will in between VIH to VOH. Okay, that we have already discussed here means to this number line. So this is all about this concept. So thank you for watching this video.